This is my lathe. I've had it for about, well, more than 35 years. That's how long I've been married. I bought it from a high school, not a Votech, a high school machine shop. I did not get an instruction manual with it, but I've done a lot of work for the last 30 years, a lot of rifle barrels, a lot of actions, a lot of jigs and fixtures, things that you could make on a lathe. This lathe has been equipped, and very common in the last 100 years or so, with a lantern or rocker type tool post. I think they called it a lantern because, you know, an old-fashioned lantern could be picked up and it had this window in it. So in older machinist text, you may find this referred to as a lantern type tool post. In more modern, I think they call it a rocker tool post. In the tool post are inserted tool holders. I think you maybe can read that. It even says tool holder. Armstrong. The tool holder then holds the tool. In this case, it's a high-speed tool. And I can adjust the height of the tool relative to the center line of the lathe. And then it also adjusts, of course, the angle of attack. This tool holder is one of many that I've collected over the years. This is a straight tool holder. This is a knurling tool. There's a boring bar holder. And for the most part, every one of the tool holders holds a 3/8 square piece of high-speed steel. Tool post slides out. About 10 years ago, my son-in-law bought me this. This is a quick change tool post. And this model is a piston style. So it would mount to the compound just like the lantern post. Now, in order to secure this to the compound, they provided with this stud threaded into this metal plate. Because this is a universal replacement, the plate is not specifically made for the T-slot. It's too thick and it's too wide. So as a universal tool post, this needs to be custom fitted to the lathe. And this fitting needs to be done on the mill. This is a sketch of the T-slot in the compound of the lathe. And this rectangular outline should be the T-nut material we're working with. And this should be the T-nut finished to slide in here. Of course, this center line is this bolt. In order to transform this piece of metal into this, I need to remove some material. I need to narrow. I need to narrow it while maintaining the center line. And so I'm going to have to remove 170 thousandths from each side. And then remove the remaining shaded area in another cut. So we'll set this all up on the lathe and see how that's going to work. I'm going to start with a 5/8 Putman. That's probably made in the United States, 4-flute end mill. The work mounted on parallels in the vise. What I'm going to do is raise the knee until I reach 0. Then I'm going to move the work under the cutter. I'm going to lower the cutter until it just touches the work. And move the work out of the way. I raise the knee 20 thousandths. Now I'll go across the work and take a 20 thousandths cut. Our goal is to remove 170 thousandths. I think I'll just keep doing it 20 thousandths at a time. One complete turn is 1/10 of an inch. And I've gone one complete turn plus 60 thousandths. Now my final cut will take me to 70 thousandths, meaning I will have removed 170 thousandths from the work. So this will be a 10 thousandths cut. At this point, I'll take the workpiece out, clean up all the chips, and invert the workpiece with the goal of removing 170 thousandths from the other side. Now, I should just be able to reset, not move up and down the knee, just reset it to 0 without moving the work. Invert the work, and I should be already touched off. So with the work turned to 180 degrees, and without moving any of the milling machine adjustments. We just touched the work. Going down to the dial, I'm going to loosen the dial, rotate it back to 0, retighten the scale, move it to 20 thousandths, and now we should be able to take a 20 thousandths cut. And I'll keep doing that 20 thousandths at a time until this end of the work is trimmed by 170 thousandths. Once again, I've got the knee locked at 0. That is the vertical movement of the table is at 0. I'm going to come down and touch off. I'm going to move the work in, away from the tool. I'm going to lower the tool, well, I'll say 40 thousandths. I'm going to move it out until it touches. Now I'm going to set the in and out to 0. I'm going to lower the table to 20. Now total vertical movement will be 94 thousandths. At this point, I'm going to move the work towards the camera 287 thousandths. And then I'm going to lock the table. I'm going to take my first cut. The previous cut took me to a depth of 80 thousandths. The goal's 94 thousandths. So I just moved it from 80 to 94. Now, usually when you're doing work on a lathe or a mill, you're trying to hit a dimension. You're removing metal until you reach a certain dimension. In this video, I've already determined what I need to remove. And hopefully if I did that accurately, the final finished work will be the right dimension. I'm going to remove the work, deburr it, and rotate it. Everything should remain the same except if I took a cut on the rotated piece, it would be 97 thousandths. So I'll return the knee to 0. Because of play in the screw, all these screws, feed screws, elevating nuts, I took it down past 0 and then brought it up to 0. So the dimensions I really try to hit, I always move in the same direction with the movement of the table. I've reversed the work piece in the vise, and I've got the knee at 0. And we're just touching. I raise the knee 20 thousandths. $40 thousandths. This is a cumulative raise. $60 thousandths. $80 thousandths. I raise the knee to 94 thousandths. With the exception of deburring and cleaning the machine up, we're done with the mill. This is the finished T-nut, deburred, edges rounded, and you see it fits fine. Put the tool post holder on top. Now understand that this dial would normally be facing, would be right above this one, to the left or right a little bit. I've got it rotated a little bit too far. Cheap Chinese metric wrench, won't fit the nut. So there we go, with the turning tool in place. I hope you liked this video and come back. Thank you.